Hi, and welcome to the 2015 Paper 2, Question 7, the first question of Section B. So we'll get straight stuck in, and just as a reminder, if you want these notes with the blank page and for your attempt and the worked examples, just send an email off to shanetroy@gmail.com. The email address is in the description as well for this video. Now the diagram below shows the right angle triangle ABC, which is used in the logo for a company. Now, we'll just mark right angle triangle, it should be important. Company called Dean Construction Limited, given the abbreviation DCL. The triangle PQR is the image of ABC under an enlargement. So we have the triangle ABC there, we have the enlargement PQR here, and that's what we're given. So the part A, part 1 here, which is about 15 C marks, is construct the center of enlargement and label it O. Now, if they ask you to label, make sure you label, because you could very easily drop from the 15 to the 11 marks by not labeling it. It's an enlargement, so if you can imagine, this was your original triangle, you had a point here somewhere, and you brought a line from the point through B onto Q. So we're looking for that original point. Obviously enough, okay, if you join Q and B and extend it, and do the same for RC extended, and or you don't necessarily need the third one, PA on, those three lines should meet somewhere around here, whatever, and that's your point O. So I have the answer done here. It's taken directly from the marking scheme, and that's that. Okay, handy enough, 15 marks. If you're kind of struggling what to do, it's an enlargement. If you think it through, even drawing lines through somewhere will get you the attempt of low partial 4. Now, part 2 then, okay, sorry, go backwards. Measure in centimeters OB, so those bars always mean the length of OB and the length of OQ, okay? And you write your answers here. So, what you're drawing will be accepted as correct, okay, as long as if it's not outside tolerance. So, whatever you measure here, so for OB, I've taken 15 from the marking scheme, I haven't actually measured it. This might be stretched, whatever. Whatever you drew on your diagram in the original paper would have been to scale. So if you are measuring it from a print off, it may not exactly give 15. Again, because the image could be stretched or just distorted to fit onto the PowerPoint page. So just take it that's 15 and take it that the OQ is 22.5. And that's the first part of question part 2 and 3, which are marked together. Okay. Now normally, if you have one part fully correct, you'd be getting the 9 here. Okay, now a 10C scale is normally 0, 3, 7, 10, but whatever happened this year, they changed it 0, 4, 9, 10. But whatever. So you will get the 9 by just getting those correct. And the part 3 there, now you're asked to use your measurements to find the scale factor of the enlargement. Okay, so your number should be making the original bigger, so it should be greater than 1. Correct to 1 decimal place. Always make sure you round it to what they ask for, or they should lose marks. And make sure there's units. Okay, in this case, it's not 1.5 units. So, although I did note the units back here. Okay, just it's centimeters in the question, is it? Actually, they don't. Oh, they do. Sorry, measure in centimeters. Okay. Now, normally if they give in centimeters in the question, they don't actually need the units, but always put units in. Don't take a chance. It can be a reduction of 4 or 5, maybe more mark over a paper. 4 or 5 marks can be an awful lot when you break it down. But anyway, so the OQ was 22.5. That was the long line. OB was 15, was the low line. Divide them together, you get 1.5. Now, sometimes it's very easy to forget which way to do it. I would suggest, if you were stuck, you just didn't know, okay, do it, say for example, both ways, okay. Scale factor, you most likely going to be able to at least go with, you're dividing those two numbers. Now, the answer will be smaller than 1, so let's just pretend it's 0.8. And you're there going, I don't know which one is right. Put both answers on the page, and the one you think is most likely to be correct, go with that. Put a line through it. Let's say I actually went wrong. Put a bracket on that and a line through it. That's been excluded as your answer, but the way the marking, as long as the person who's marking is doing their job right, if they see the correct answer there, they're to ignore what you declared and give the full marks for this. Okay, can't do it too often. Not very many places that it works, okay, but this is one of the situations where that would work very well. So that's part 3. Now move on. So the part B here is worth 5 marks. The area of the triangle ABC is 7.5 centimeters squared. Use the scale factor to find the area of the image triangle PQR under the enlargement. So use the scale factor, okay, to find the image of the new triangle. It's basically its area. There's actually a formula for that. So the area under enlargement is given by area times the scale factor squared. So that's the example of one of the formulas you have to memorize. Now, if you couldn't remember the formula, if you multiply the area by the scale factor, you'll get the 3 marks. Okay. The actual answer, though, is scale factor was 1.5. The area given in the question is 7.5, so that's the known data. Put them into the formula, 7.5 times 1.5 to be squared. Make sure the calculator you do is right. Okay, you're only squaring the 1.5, not the answer. I come up with 16.875, and that unit there is centimeters squared. Okay, so that's pretty handy down. As long as you know the formula, dead easy. Now, part C here, there's 3 parts together are worth 5D. So you see a D scale has a lot more breakdowns. If you get 1 part correct, you get 2 parts correct, you get probably the 4 actually. And then there's just a grade in between if you've significant work in 2 and not in the other. Now, part C, part 1 says, given that the length of some of those bars means the length of AB is 5 centimeters, use the scale factor. Now, whatever scale factor you've got in the previous answer, if you're using that, even if it's wrong, will be accepted as correct here. So let's say you couldn't get a scale factor in the previous question there, or in any question like that, just make it up. You get nothing for that part where you try to find a scale factor because it's wrong, but the number you put in there will be accepted as correct in all other parts after that. So pick an easy number to multiply or work with, okay? So use the scale factor, which is 1.5, okay, to find the length of PQ. So basically it's 5. Now, the ABC is a smaller triangle, PQR was the enlargement. You're multiplying 5 by 1.5, and you're getting actually 7.5. So see there, that's the workings there, okay? As I said earlier, email me and I'll send you these on, you'll have them in front of you. So that's my answer, just declared. It's always a good thing, if you have space, declare your answer. You know, if you want to go crazy, different color pen or something, or just a box around it is perfectly fine. And it does make marking the exam easier. If the person who's marking is having an easy time doing it, they're more likely to give you benefit of the doubt in a question where they can, okay? Or just be less frustrated marking your paper. So that's part 1. So I'll go back here now. Part 2. Given that the length of QR is 8.7, now remember QR is the enlargement, use the scale factor to find BC, which is the original, the smaller shape. Okay? So I'll show you here, you probably saw already. So QR is equal to BC times 1.5. Okay, now QR was 8.7. So I've thrown that in there. Brought the 1.5 across. It was multiplied on the right, becomes divided on the left. I end up with this sum here. And that divides in to give you an answer of 5.8. Okay. So it was kind of a little bit different than the first one. But if you know what you're doing, it's pretty handy. Just make sure you do go back and look at the diagram itself. Have it here embedded just for clarity, okay? And it should hopefully help to make sense of what's going on. Now the third part here, so hence, okay, I hate that word, show that the size of the angle ABC, is equal to the angle PQR. Okay. Now, it's a right angle triangle, so sine cos tan rules come here. So if you think of it angles, sine cos tan is probably going to become in play. I'm going to find the angle ABC, find the angle PQR, and then from there be able to be sure that they are equal or not equal. So I've done it here, okay, I'm using cos. So if you look at this, you're looking for the angle, let's see, ABC. So if you can see here, it's that angle I'm marking there. It's a right angle triangle. Okay, I have the length of the hypotenuse is 5. That's the BC. I have the length of, no, what's going wrong here, 5.8. BC. The length of AB is 5. Actually, I've put these wrong. That 5 should be here. And the 5.8 should be here. The reason I got confused there was the hypotenuse has to be the longest side. So whatever I've done wrong there, I put the numbers the wrong way around. I might fix that on the package later on after I finish, okay? It'll be done right here though. So I have the adjacent is 5. So if this angle you're looking for, that's the opposite. Put O for opposite. That's A for adjacent, excuse the marker, and H for hypotenuse. So the cos ratio is looking for the adjacent over the hypotenuse, that fraction. So it's 5. Now it says 5.8. Remember, that was a mistake. So it's 5 over the hypotenuse, which is 5.8. So that's there. So that fraction corresponds to whatever the angle is for ABC. And I don't actually need to find the angle. Okay, I could if I wanted to, but I don't need to. If that fraction equals the other fraction, then the angles are equal. So I'm looking for cos PQR. Now this is done correct, so the apex 7 is longer. The hypotenuse should be the longer side. The adjacent there is 7.5. So again, this is the angle I'm looking for here. Okay, so this is the opposite. This is the adjacent. This is the hypotenuse. So I'm looking for cos of that angle, which is the adjacent 7.5 over the hypotenuse 8.7. So if those two fractions are equal, then the angles will be equal. Now it may not look like it, but if you turn them both decimal, 5 divided by 5.8 is the same thing as the decimal of 0.862. Do the calculator 7.5 divided by 8.7, I'll also get the decimal of 0.862. So you see 0.862 equals 0.862, therefore both angles are equal. Now you could go and find the angles and then state the angles being equal. But then you'd have to find the inverse cos of both those fractions, which is it's more work, and it's not necessary. So that's part C, 1, 2, 3. Okay, that's the end of question 7. So thanks a million, and look forward to seeing you soon.